minus over here, negative 2.9. So my average weight change, or the observed difference, is 1.5. So far, the miracle weight loss pill seems more effective in that they lost, on average, 1.5 pounds more than the placebo. Okay? So this is my observed difference. If the null hypothesis were true, we would expect the average weight change, the difference between weight changes, to both be, the difference between weight changes to be 0. Okay, if they were equally effective, if placebo users lost 1.4 pounds, we would expect the miracle weight loss pill users to also be 1.4 pounds. We expect that difference to be 0. What we saw is a difference of 1.5 pounds, and we want to know what's the probability of ending up out there. So here we're going to find not a z-score, but a t-score, right? I'm going to do 1.5 minus the mean divided by the standard error. So I got to figure out my standard error. Okay? So my standard error is square root of what? 1.2 squared over 24. Or I'm labeling my things wrong. Group 1 and group 2. So I start off with group 1, 1.1 squared over 26 plus 1.2 squared over 24. Okay? This is just, we're using the formula for the standard error.
Right.
Okay? .326. So we've got .3264. Okay, so my t-score is equal to 1.5 minus the mean of 0 divided by 0.3264. And I get 4.596. Okay, so our t-score is 4.596. Is this all right? All right, so what is my p-value? How much is in my tail? Can we figure this out? Well, I got to know my degrees of freedom. How many degrees of freedom do I have? 23 degrees of freedom. All right, I know. Class is almost over. Just stick with me, all right? I got 23 degrees of freedom because I'm using n minus 1, and I'm using the smaller n, right? So I got 23 degrees of freedom. My number is 4.596. So what's my tail area? I'm not sure what you just said there, but my tail area is less than 0.001. Okay? Is that all right? And that's my p-value. Are we okay? P-value less than 0.001? Yeah, I'm just talking about class here. Are we okay with what's going on here? The p-value is less than 0.001. If my t-score, I got my t-score to be 4.596. I look that up in my table with 23 degrees of freedom, and I get a p-value of less than 0.001.
Yes.
I hope we're good. All right, so my p-value is less than alpha. So then what do I do? I reject the null, okay? So let me just erase some stuff up here. just hang on. Just a few more minutes, guys. Alright, so my p-value is less than 0.001. My p-value is less than alpha. So I reject the null hypothesis. What was my null hypothesis? That the placebo is equally effective as a miracle weight loss pill, okay? So, to answer our question, does this provide evidence that miracle weight loss pill is more effective than placebo? Yes. We do have evidence. We have evidence that the miracle weight loss pill is more effective than placebo. Okay? But how effective is it? It's the average, sample average was a weight loss of about 3 pounds, okay? And with placebo, people lost an average of maybe 1.5 pounds. So there is evidence that it's more effective than placebo. But, how much will they charge? Who knows, right? Is it worth spending, $100 for, or whatever, 4 easy payments of $40 or whatever to get this kit that will help you lose an extra 1.5 pounds than the placebo? I don't know. It depends on who you are. But, if they say it is more effective than placebo, their claim might be correct. Okay? They might not be lying. But the results about how effective may not be that significant. Okay, yes, question?
How do we know if it's more effective?
What we're observing is that people who use the pill lost more weight than people who use placebo. That's our data. Our data shows that people who use the pill lost more weight than those who use placebo. So that is kind of our evidence showing that it is more effective than placebo. Okay?